Okay, this is section 5.2, and we are going to talk about more systems of linear equations, but now we're going to talk about systems of linear equations with three equations and three unknowns. So we talked about a linear equation in two variables has an infinite number of solutions called coordinate pairs, x, y. Those solutions are represented in the Cartesian plane by a line. Hence, we call them linear equations. So here's a line, and it has the equation y equals 3/4 x plus 2. And you can see that that equation right there has an infinite number of solutions that all lie on the line. So -4, -1, you put it into this equation, you get -1 equals 3/4 times -4 plus 2, and that's a true statement. If you put in 0, 2 into the equation, you would have 2 equals 0 plus 2, which would be true. So every single point on this line satisfies this equation, and that's why the graph represents the equation. So every linear equation in two unknowns has an infinite number of solutions, coordinate pairs that all lie on a line. A linear equation in three variables, which is what we're going to look at now, has an infinite number of solutions called ordered triples, x, y, z. Those solutions are represented by a plane in three-dimensional space. So the x, y, z plane that has three axes, and so you can see that this equation represents a plane, a flat surface, where all the points that work in the equation sit all over this thing. There are points, and all those points will work in the equation. The solution to a system of two equations in two unknowns is an ordered pair, which satisfies both equations and is represented by the point of intersection of the two lines. So this is the graphic representation of the solution to a system of two equations in two unknowns. It's two lines that cross, and that point of intersection is the solution to the system. The solution to a system of three equations and three unknowns is a coordinate triple, x, y, z, which satisfies all three equations and is represented by the point of intersection of the three planes. So let's just determine if the ordered triple is a solution to the system of linear equations. If you look at part A and you put that point into every single equation and it works, you'll know that it is a solution to the system. So if I put in 3, -5, 1 into the first equation, I've got 2 times 3 plus -5 minus 3 times 1. And that is going to be 6 minus 5, which is 1, minus 3 is -2. So that works. Second equation, you've got x. So that's 3 minus 4 times -5 plus 1. And that is 3 plus 20, which is 23, plus 1 is 24. So that does work. The third equation, put in 3, -5, 1, and see what happens. So you've got -3 times 3 minus -5 plus 4 times 1. And that is -9 plus 5, which is -4, plus 4 is 0. So yes, this is a solution. A is a solution. If you try part B, if you try putting in that point, you have 2 times 2 plus -3 minus 3 times 1. And that's 4 minus 3, which is 1 minus 3, which is -2. That works. Second equation, put it in. You've got x, so 2 minus 4 times -3 plus 1 equals 2 plus 12, which is 14, plus 1, which is 15. So that does not work, which means that no, that is not a solution to the system. So to solve a system of three equations and three unknowns, we use elimination. And just so that we don't get completely confused about what we're doing, I'm going to go ahead and name each equation A, B, and C, since when I'm talking about it, I want you to know which equation I'm talking about. All right, so what you have to do is take two of the equations and eliminate one of the unknowns. and then you take two other equations and eliminate the same unknown again. And that way you reduce this system of equations to two equations and two unknowns, which we already know how to solve. So it looks to me, if you look in the y column here, you've got negative 2y, positive 1y, and negative 3y. This looks like something that will be easy to get rid of the y's. It also looks pretty easy to eliminate z's. The x's are more difficult because they have coefficients that are not multiples of each other. None of them is 1. So I wouldn't try to eliminate the x's. So what I'm going to do is take equation A and equation B and use those two equations to eliminate the y's. So I'm going to rewrite them. 3x minus 2y plus z equals 2, and 5x plus y minus 2z equals 1. So if I look at these two equations now, this is equation A and equation B, I can eliminate the y's if I multiply the second equation by 2. That will make the y's opposite. So I'm going to rewrite this equation, multiplying it by 2. So I'm going to put a little 2 there to remind myself what I'm doing. I'm multiplying it by 2. So 10x plus 2y minus 4z equals 2. The top equation, I'm not going to do anything to it. I'm just going to rewrite it. 3x minus 2y plus z equals 2. And now I am going to add these two equations together, and I can do that because I'm adding the left side of the equation is equal to the right side, and that means I'm adding the same thing to both sides of the equation. So 3x plus 10x is 13x. The y's go away, and a minus 3z is what I get here, and then 4. All right, so now I have this new equation that I've created that has just x's and z's in it. I want to get another equation that has just x's and z's in it, and that way I'll have two equations and two unknowns. So I'm going to go back to the original equations, and this time I'm going to use B and C. Before, I used A and B, and that got me this new equation, which I could call D. And now I want to go back and use B and C to try to get another equation with just X and Z in it. So I'm going to, if you look at these two equations, B and C, if I want to cancel the y's, which I do, I want to cancel the same thing I canceled before, I'm going to have to multiply the B equation by 3. So I'm going to write them out just not to get confused. I'll write B again, 5x plus y minus 2z equals 1. And then I'll write C, 4x minus 3y plus 3z equals 7. And now I am going to multiply the top equation, that equation B, by 3. That way the y's will have opposite coefficients and they will cancel. So I'm going to multiply by 3. So that's 15x plus 3y minus 6z equals 3. I'll write the second equation again exactly the way it already is and add them together. I'll get 19x, the y's cancel, minus 3z equals 10. All right, so now I have another equation in x and z. I'll just call it E. And now I will put those two equations together and solve for x and z. So I'll have the D equation, 13x minus 3z equals 4. And the E equation, which is 19x minus 3z equals 10. So I can see here that if I just multiply either one of these equations by -1, the z's will be opposites and they will cancel out. So I'm going to multiply the top equation by -1, and I'm not going to write that out because I think you can follow me on what I'm doing here. I'm just multiplying that top equation by -1 and adding it to the second equation. So I'll have -13x plus 19x will give me 6x, and then I'll multiply the -3z in the top equation by the -1, and I'll get 3z. So the z's will cancel. And then on the right side of the equation, I've got -4 plus 10 will give me 6. That gives me x equals 1. So I know so far in my coordinate triple, I'm going to have 1 for my x. Now I can take that 1 and plug it back into one of these equations, E or D, and figure out what z is. So if I plug it in here, I will get 19 times 1, so I'll do that. I'll do that down here. 19 times 1 minus 3z equals 10. So negative 3z equals negative 9. So z is going to be 3. So I can put that into my ordered triple for z. Now I can go back to any of the original equations and plug in 1 and 3 for x and z and see what I get for y. So I'm going to plug it into equation A. So I'll have 3 times 1 minus 2y plus z is 3 equals 2. So that's 3. So if I get y by itself, I'm going to have negative 2y. I'm going to subtract 6 on both sides. I'll have negative 4, and y will equal 2. So my ordered triple is 1, 2, 3. I can go back into the original equations and check those values. So for equation A, I plug in 1, 2, 3. I'm going to get 3 minus 4 plus 3 is supposed to equal 2. 3 minus 4 is negative 1, plus 3 is 2. That works. If I look at equation B and put in 1, 2, 3, I get 5 plus 2 minus 6, and that is 1. That's true. For equation C, I'll put in 1, 2, 3. I will get 4 minus 6 plus 9, and that's going to be 7. So yes, that works. This is the solution set to this system of equations. Okay, here's another system of 3 equations and 3 unknowns. This time, not all of the equations have all of the variables or all of the unknowns, but I still do it the same way that I did the other one. I'm going to take 2 of the equations and eliminate one of the unknowns, and then I'm going to take the 2 other equations and eliminate that same unknown. So if I go ahead and call these A, B, and C, just so we don't get confused, I'm going to take equations A and B, and I'm going to eliminate the y's. So even though the equations only have 2 of the unknowns in them, I'm going to leave a space for the third unknown just so that I have everything lined up. So that first equation A, I'm going to rewrite as 2x plus y plus 0z equals negative 2. The second equation, I'll put the 3y in line with the y. I'm going to subtract z on both sides of that. So I'll have negative 5z. I don't have an x in that equation, so I'll put 0x for that. And then the negative 12 is over there on the right. So these are equations A and B, just rearranged a little bit. Now I want to eliminate the y's. So I'm going to multiply the top equation by negative 3. I'm going to multiply it by negative 3, and I will get negative 6x minus 3y plus 0z equals 6. Second equation, I'm going to leave it the way it is. Minus 5z equals negative 12. Add them together, and the y's cancel, and you end up with negative 6x minus 5z is equal to negative 6. Okay, so this is my new equation in x and z. We'll call it equation D. And I now have 2 equations and 2 unknowns because c is already in x and z. So I'll bring c over here and get everything on one side except for the constant. So if I do that, over here I've got 5x plus 5z equals 2z plus 5. So if I rewrite this in standard form, with just the constant on the right side, I'll have 5x plus 3z equals 5. So that's the equation I'm going to put over here. 5x plus 3z equals 5. And now I want to solve this system of equations. So to do that, I will multiply D, the D equation, by 5, and I'll multiply the C equation by 6. That'll make the x's cancel. I'm going to multiply it by 5. That's just to remind me what I'm doing here. So that's negative 30x minus 25z equals negative 30. And then I'm going to multiply the c equation that I rearranged by 6. So 5x times 6 is 30x, and then plus 18z equals 30. So if I add these together, I'm going to get 7z, negative 7z, equals 0, which means that z is 0. So up here, where I'm going to put my solution, I will put 0 in the place where z goes. Now I'm going to take that 0 and plug it back into any one of the equations. I might as well go back to one of the original equations and plug it into something a little easier than what I have now. I'm going to plug it into the b equation because that looks easy. So 3y equals 5 times z, which is 5 times 0, so that's 0 minus 12, which means that y is negative 4. So y equals negative 4, so we'll put that up here in our solution. And then to find out what x is, I'm going to go back to equation A and put negative 4 in there for y. So 2x minus 4 equals negative 2. So 2x is equal to 2, so x is 1. So I'll put that in for x. All right, a system of linear equations of three unknowns may have no solutions. In that case, we say the system is inconsistent. And this happens graphically. It happens when the three planes, that's what the three equations represent, do not all intersect in one point. These three planes don't intersect at all, with all three of them don't intersect each other. And then the second situation here is two of the planes are exactly the same. And then the other plane is parallel to that plane, so they don't even touch. And then over here on the last one, all three planes are separate. They are parallel to each other. They don't touch at all. So that would be an inconsistent system, and that would be, if you were working it out, you would get a contradiction at some point when you're working it out. Like you would get something like 0 equals 2, and that's not true. So either you made a mistake or the system is inconsistent, and we'll see that in an example. Also, a system of linear equations and three unknowns may have an infinite number of solutions. We say that the system is dependent. So this happens when maybe, like in this first situation, two of the planes are the same and they intersect the other plane in a whole line of points. Or maybe in this second picture, they're trying to show you that the three planes are all the same. They're exactly the same thing. So they have an infinite number of points that they share. And this last one, the three planes are all different, but they do intersect in one line. So they have an infinite number of solutions. And when you have a dependent system, something will happen when you're doing it algebraically. You will find out that something like 2 equals 2, and you will say, yes, that's true, but that doesn't really tell me what the solution is. That's what the situation is when you have dependent equations. So we've got these three equations. I'll call them A, B, and C again. And we will try to eliminate, well, it's very easy to eliminate the x's in the first two equations. So if I add equation A to equation B, I don't even have to cancel. I don't have to multiply by anything, and the x's will cancel. So if I do that, I'm going to get negative x plus x is 0x, and 6y minus 2y is 4y, and then negative 3z plus 2z, that's minus z, and negative 8 plus 3 is negative 5. Okay, so I have a new equation now in two unknowns, y and z, and we'll call that equation D, just so I don't confuse you. All right, so now I need to eliminate the x in the third equation, and to do that, I will just, I will work with equations A and C this time. So equation A, I'll rewrite right here as negative x plus 6y minus 3z equals negative 8. And then equation C, I will rewrite here as 3x plus 2y plus 4z equals negative 6. And now I will multiply the A equation by 3. So I'm multiplying it by 3 so that it will cancel the x in the second equation. So that'll be negative 3x plus 18y minus 9z equals negative 24. Second equation C is just the same. I'm not going to do anything to that. And now when I add them together, the x's cancel, and I end up with 20y minus 5z equals negative 30. So now I have this new equation. We'll call it E. All right, so if I put D and E together here, 4y minus z equals negative 5, and 20y minus 5z equals negative 30, and I tried to do elimination on those. Let's say I multiply the first equation through by negative 5 to eliminate the y's, then I will have negative 20 plus 20 will give me 0y, or just 0. And then 5z minus 5z is going to give me 0, so that's 0. And then negative 5 times negative 5 is 25, minus 30 is negative 5. So this tells me that 0 equals negative 5. That is not true. 0 does not equal negative 5. So this system has no solution. They are inconsistent, and the solution set is the empty set. Okay, here's another situation. We want to determine the number of solutions to this system. So I'm going to go ahead and call them A, B, and C again. All right, so I'm going to use A and B. I'm going to eliminate the y's. So I could take equation A and multiply it by negative 2. That is going to give me negative 4x minus 2y equals 6. And then equation B, I'm going to leave it the way it is, 2y plus 16z equals negative 10. When I add this together, the negative 4x is right there, and then I've got negative 2y and a positive 2y, so the y's cancel. And then I've got plus 16z is equal to, so now I have an equation in just x and z, so we'll call that equation D. And now I want to go back and take B and C, or A and C, and cancel the y's again. I got to cancel the same thing I already canceled. So I'm going to use A and C. So equation A, got 2x plus y equals negative 3. And equation C is negative 7x minus 3y plus 4z equals 8. So if I were to multiply that first equation through by 3, my y's would cancel because I'd have a 3y and a negative 3y. So I don't have much room. I'm going to come down here. So I'm going to multiply that first equation by 3. So multiplying it by 3. So I'll have 6x plus 3y equals negative 9. And I'm going to leave this equation the way it is. So negative 7x minus 3y plus 4z equals 8. And I'm going to add those up, and the y's will cancel, and I will have negative x plus 4z equals negative 1. All right, so I have this equation, equation D, negative 4x plus 16z equals negative 4. And then equation E, I've got negative x plus 4z equals negative 1. I'll multiply the second equation by negative 4. And if I do that, I'm getting negative 4x plus 4x will be 0x. And then I'll have 16z minus 16z, which will be 0z. And then I'll have negative 4 plus 4, which will be 0. That is true, but it doesn't really tell me what the solution is, and that's because there are an infinite number of solutions. So there are infinite solutions, and these are dependent equations, and the solution set. So what I'm going to do is I am going to figure out how these three unknowns are related to each other, how they depend on each other. And to do that, I'm going to look at equation A and solve it for x and write x in terms of y. So if I do that for equation A, I've got 2x equals negative y minus 3, and therefore x equals negative y minus 3 over 2. Now I'm going to take equation B, and I'm going to write z in terms of y. So if I do that, I will have 16z equals negative 2y minus 10. And so z is equal to negative 2y minus 10 over 16. And that is equal to y minus 5 over 8. Okay, so now I know how x relates to y and how z relates to y. So now I can actually write the solution set just showing a little more information than just saying x, y, and z are real numbers, because I know how they depend on each other now. So my solution, I would say, I would write the coordinate triple as, for x, I would put negative y minus 3 over 2. For y, I would just put y because I'm writing the two other unknowns in terms of y. And then for z, I would have y minus 5 over 8. And that would be every coordinate triple, and y is a real number. Y is an element of the reals. So this would be a way to write this solution set showing how the three unknowns are related. Now we have an application. Jeanette invested a total of $18,000 in 3 different mutual funds. A bond fund returned 4% the first year, an aggressive growth fund lost 8% for the first year, and an international fund returned 2%. Jeanette invested $2,000 more in the growth fund than in the other 2 funds combined. If the net loss was $540 for the year, how much did Jeanette invest in each fund? Okay, so this is going to be 3 equations and 3 unknowns. We know there are 3 unknowns because the question is, how much did Jeanette invest in each fund? And there are 3 different funds. There's a bond fund, there's an aggressive growth fund, and there is an international fund. Okay, so those are going to be our 3 unknowns. We'll just call them X, Y, and Z. X is the bond fund. It's going to be the amount she put in the bond fund. Y will be the amount she put in the growth fund, and Z will be the amount she put in the international fund. So our first equation, it tells us that she invested a total of $18,000. So the amount she put in the bond fund, plus the amount she put in the growth fund, plus the amount she put in the international fund, all adds up to $18,000. Then it tells us how much she earned the first year from each fund. So the bond fund returned 4%. That means she earned 0.04 of that amount that was in the bond fund. It says that the growth fund lost 8%. So that means she lost minus 8% of that money that was in that fund. And then the international fund returned 2%. So she earned 0.02 of that money for the year. And her total net loss was $540. So this was not a net gain for her. It was a net loss for that year. So that year she lost $540. So the total of how much she gained, lost, and gained in the 3 funds turns out to be a negative amount. Sorry, I didn't leave enough room for the negative sign. So negative $540. That turns out to be a net loss. All right. And then it says she invested $2,000 more in the growth fund than in the other 2 funds combined. So the growth fund is Y. That amount is $2,000 more than the other 2 combined. So X plus Z combined. So these are our three equations, and now we just want to get them looking a little more easy to work with. So the first one's fine the way it is, x plus y plus z equals 18,000. The second one, I'm going to multiply by 100, so I don't have those decimals. So I'll have 4x minus 8y plus 2z equals negative 54000. And then this last equation, I'm going to put everything except the 2000 on the left side. So minus x plus y minus z. So these are my three equations. Okay, so the x's look very easy to get rid of. First of all, equations A and C, if you add those together, equation A plus equation C, the x's and the z's are going to cancel, and you're going to end up with 2y equals 20,000, which means that y is 10,000. So I'm going to go take two other equations, like B and C, and add them together and eliminate the x's again. So I'm going to do B plus 4 times equation C. So instead of doing all that out, I'm just showing you what I'm doing. So if I do that, I will have 4x minus 4x, which will be 0x. And then I'll have negative 8y plus 4y, which will give me negative 4y. And then I'll have 2z minus 4z will give me negative 2z. And then I will have negative 54,000 plus 8,000 is going to give me negative 46,000. So now I can go ahead and put in 10,000 for y. So I would get negative 40,000 minus 2z equals negative 46,000. And add 40,000 on both sides. So negative 2z is equal to negative 6,000. So z is 3,000. All right, so now I know y and z, so just go ahead and fill those in. Z is 3,000 and y is 10,000. And since she invested a total of 18,000, that's 13,000, so the other fund would be 5,000. So bond fund, 5,000. Growth fund, 10,000. And international fund, 3,000. Amazingly, it is true that any three non-collinear points, that is, any 3 points that do not fall on the same line, define a unique parabola. We're going to figure out how to find that specific unique parabola given 3 points. So given the non-collinear points for 2, 1, negative 1, and negative 1, 7, find an equation of the form y equals ax squared plus bx plus c that defines the parabola through the points. All right, so we have the equation of a parabola, y equals ax squared plus bx plus c, that contains these 3 points. So all we need to do is figure out what the coefficients are of our parabola. And the way we can do that is to plug in the points for x and y, and we'll have 3 equations and 3 unknowns, a, b, and c. Once we find the coefficients, we can then write the equation. So we know that 4, 2 is a point on this parabola that we're looking for. And so we'll plug that in. Y will be 2. And then we'll have a times x squared. So that's 16a, because a is 4 in this point, plus bx. So x is 4 again, 4b, and c. All right, next we'll put in 1, negative 1 for x and y. So y is negative 1, we'll put that there. X is 1, so we have 1a plus 1b, and c is just c. All right, now we're going to put in the third point, negative 1, 7. So y is 7 for that point. And we have negative 1 for our x, so negative 1 squared is 1, so we just have a again. And then -1 is x, so we have minus b here, and c is just c. So again, all we're doing is we're taking the general form for the equation of a parabola, y equals ax squared plus bx plus c. This is what we're looking for, this unique parabola that goes through these 3 points. And since it goes through these 3 points fit into the equation, they work in the equation. So we just plugged in the points for x and y, and we got these 3 equations and 3 unknowns. The 3 unknowns are the coefficients of x squared and x, and the constant c. Now all we have to do is solve this. So we can easily eliminate the b's by just adding the second 2 equations. So we'll call these a, b, and c. And I'm just going to add equation b to equation c. And when I do that, I will get 6 on the left side, 2a, the b's cancel, and I'll have 2c. So that got rid of the b's on that one, and I'll go and I'll use a and c to get rid of the b again. And I'll bring it over here. All right, so that'd be 30 equals 20a plus 5c. And now I can multiply the equation. I'll multiply the top equation by -10 to get rid of the a's. And I get -30 equals -15c, so c is 2. Now if I go back and plug c in to, I'll plug it back into equation d. So b is going to be -4. So these are the coefficients of the parabola. So it's going to be y equals x squared minus 4x plus 2.